Okay, so today we're going to do 101, page 101, 2.4, Investigating Symmetry. And the first thing that I want you to make a note of is there's two different kinds of symmetry. There's line symmetry and rotational symmetry. So the first thing we're talking about is line symmetry. And a figure has symmetry if a rigid motion exists that maps the figure onto itself. Line symmetry is if a reflection maps the figure onto itself, and each one of those lines would be called a line of symmetry. So if you look over here at this crescent moon shape, here would be the line of symmetry, and you can see that if I flip that over, that those two corners would match up perfectly with each other, just lay on each other perfectly. So let's look at this first example down at the bottom. I'll sketch any lines of symmetry that this figure has, and if I draw a line right down the center, I can tell that everything's going to match up, and that would be the only line of symmetry I can draw. Now turn to page 202, and let's look at these examples. This box has a line of symmetry here, and it also has one there. So that rectangle has two lines of symmetry. This is a scalene triangle. And a scalene triangle is a triangle that has no sides equal to each other. I'm going to try to write that a little better, and it didn't happen. Okay, so this has 0 lines of symmetry. Now this L, if I draw a line right through there, it would match up by flipping it over. And so it has 1 line of symmetry. Okay, so now we're going to move to the bottom of the page, and we're going to talk about rotational symmetry. Okay, and a rotational symmetry is if a rotation maps the figure onto itself. And the angle of rotational symmetry is what is important. And so if we look here, we can move this here and it maps directly onto itself. And the way we find the angle of rotational symmetry is we take 360 and we divide it by 1, 2, 3, 4, 5. 5 points. And we get that 72. And so there would be an angle of rotation at 72. There'd be an angle of rotation at 144. There'd be an angle of rotation at 216 and 288. And all I'm doing is adding 72 to each one of those. So I could rotate it to here. I could rotate it to here. That would be my 144. I could rotate it around to here, and so on and so on. Okay? So now we're going to turn to 103 and determine whether each figure has rotational symmetry, and it wants the angles. So this has 4. 360 divided by 4 is 90. And then we have 180 and 270. Again, the scalene triangle will have 0. And this arrow, it would take 180 degrees. There's only 2 points. 1, 2. 360 divided by 2 is 180. And that's how you would get that. Okay? So let's look down at B on page 104. And we're going to look for lines of symmetry here. Here's a line of symmetry. If I flip that thing over, it maps right on itself. Here's another one, and here's a third one. So it has 3 lines of symmetry. Now, angles of rotation. Well, if I move this to here, it's going to look just like it does. Same thing if it moves here. And so 360 divided by 3 gives me 120, and then also 240. Okay, so if you've turned page 105, I want you to do 6 and 7, and then check back in, pause the video, and then check back in and see if you've done them right. Okay, so 6 has both line symmetry and rotational symmetry. And as you can see, I drew 4 lines showing you the lines of symmetry, and 360 divided by 4 gives me angles of rotation at 90, 180, and 270. Number 7 only has line symmetry, and there's only one line that you can do that with. And that's it. See you tomorrow.